So, hello and welcome to the Slackware ARM podcast. I'm Stuart Winter, the platform architect and lead developer of the project, which is the Slackware Linux distribution on the ARM platform. And we also have with us Brent. Hi, Brent.
Hello.
How are you doing?
Okay.
Still doing good, because Brent and I have been working together on this project for a couple of years. If you're new to the channel, Slackware ARM is basically the official port of the Slackware Linux distribution. It's been around for about 20 years now. Started off with being 32-bit back in 2005 or something like that, and has progressed to where we are today, which is running on the 64-bit ARM platform. Brent and I work together as a hobby project in our spare time, and put it to you guys because it's a bit of fun. Now, the thing is, is that what happened was earlier today, we recorded the vlog, the latest episode. The problem was that I forgot to hit record on the video conference tool, but I did record the screen recording, which was separate. So we have the screen recording, but we didn't have the audio. So I thought, why don't we do a sort of director's commentary on what we did about 3 hours ago? So that's what we're going to do. So we're going to play the video like you see the directors do in the movies, and we'll just say whatever comes into our head. Try and remember what we did earlier, and show you what's going on. But so let's play the video. Can you see the video playing, Brent? So you should have the mouse. Okay.
Yeah.
So yeah, I'm just showing you the video from earlier. Okay. So let's just skip through here a bit. Okay, so we start off with the MacBook Pro. And the reason why we were showing you this was because my work machine is a MacBook Pro, and it is an ARM 64 machine. I think it's 16 cores, and as you can see, it's 16 gig of RAM, and it's an Apple M2. So what I might do once or post Slackware 15.1 release, which ships with the Linux 6.1 kernel, and that's the plan anyway. Once that's released, we'll be able to upgrade to the latest kernel, which I think has support for the M2. So there's a couple of virtualization options available on the Apple M1 and M2. I think it's UTM and parallels. I think those are the options. So a couple of people in the community have already been looking at how to get Slackware AH64 running inside of virtualization. So I'll probably just make that happen post 15.1 release for a bit of fun, really. I'll see how fast it is. Maybe it will be helpful in the build process. I don't know, to be honest. But that's the plan anyway. That's why I was showing you that. So that'll be just a little bit of fun to play around with. It'd also be a good way to expose, or rather to exhibit, what the way that you can bring Slackware onto other hardware models. How can you add support in? So we can show you how it's done. Right. What the plan of this podcast was that the operating system initial RAM disk and the Slackware installer are they're generic. Right. On ARM, you can't. It's not like x86. There's no BIOS, so you can't probe what's plugged into it, and therefore know what modules to load. You have to have a basically, you need to know in advance what the hardware is, so you know what to load yourself. And there are different ways of doing this, but the way I've implemented it in Slackware is based on the idea of the flattened device tree. So I just took the concept really and turned it into shell script. So that's basically where it came from. I didn't invent the original concept. I just thought that looks like it works actually. So let's re-implement that in shell script. So the Slackware AH64 installers are basically back to front in relation to the x86, where we carry a whole bunch of different support for hardware and mostly hardware that your machine will never probably use. But we do that first of all because there's enough RAM in these machines to do so. But also it means that it makes everything a heck of a lot easier to onboard new hardware models, because all you normally need to do is just identify the hardware. Oh, I'm going a bit too far. Identify the hardware model and then load the appropriate modules. As long as the modules are actually there to be loaded, it's great. And it works so far because we've been doing this for 2 years and it seems to work really well, and it does make onboarding new hardware models actually relatively easy.
Yeah.
At least inside of the OS anyway. It's actually pretty it's a piece of cake. It's only the bootloader stuff that's a bit of a
Yeah,
pain.
it's always a bootloader.
Bloody bootloader. So yeah, so basically it works. Anyway, however, when I was originally designing it, I just captured the majority, the sort of main subsystems like storage and network, USB, SCSI, and PCI and stuff. I captured the main subsystems that you would need to light up in order to access the storage on which the Slackware operating system lives. So usually that would be a hard drive, SSD, whatever. So if that's plugged into the USB bus, then I need to bring up the USB subsystem. I need to load the kernel modules to bring it up. If it's on SCSI, likewise, and blah blah blah. And if it's the SCSI card on a PCI bus, well, you need to bring the PCI bus up as well. So the thing is that we can do all of that, but we need to have the modules there. And I'm not shipping a different kernel for every single hardware model, because that's absolutely insane. And I know that because I used to do it when I first started the project, and it's never happening again. And Linus Torvalds said it wasn't either, and I go with what he says. Seems like a smart enough guy. It's certainly smart to me anyway. So whatever he says makes sense to me. So what that means is that the Slackware ARM has a generic kernel, that it's the same kernel, the same package, and you run it on everything. It doesn't matter about the hardware model. And we can do that because we give you a big fat suitcase full of several suitcases full of kernel modules. So the thing is that what's happened is, in the end, it's got a little bit heavy because I've been arbitrarily adding, well, not arbitrarily, I've been taking carte blanche on just adding stuff into the initial RAM disk. Oh, we need a bit more of that. Let's put the whole thing in. And I've been replacing.
See if this boots on those Raspberry Pis.
What's that?
See if that boots on a Raspberry Pi.
Raspberry Pi. Well, this is the problem. So basically, as I add more modules into the kernel for support within the OS, it does inflate the kernel, the amount of kernel drivers or modules we have in the OS InitRD. And basically, inside of the OS InitRD and the installer, these are just really small environments that run from RAM, and they shouldn't need a huge amount of support for anything. They don't need Bluetooth, they don't need wireless and all that kind of stuff. For example, all they need to do is to access the storage to boot the OS. Well, it's not strictly true with the installer, but it doesn't matter. So really what I'm saying is that we need to have a smallest set of, we need to have a useful set that enables us to support new hardware models easily. We need to have a small enough set, but not too much. We need to strike the balance between ease of bringing on new hardware models versus actually supporting what we already have. So what happened is Brent said, well, we used to be able to boot the installer on the Raspberry Pi 3 that he has, but now it's the out of memory killer kicked in and killed everything. Yeah. And most likely because the InitRD is increased in size. And I did expect this to happen. There's actually a note in the code to say that at some point we're going to have to visit this for sure. So that day came, and what we've done is Brent has, and I have gone through, we've revisited the included list to some degree and found things that we just don't need. We think we didn't need. So what we're doing in this video is we're just testing those assumptions. We're going to go into the initial RAM list. We're going to delete a load of stuff and then bring it up and see how it works. And if it goes wrong, we'll fix it. Okay, that's what we're doing. We're testing this basically to see how much rubbish. Sorry, how many subsystems we can lose without breaking anything. This script that we're looking at here is included. It's executed from the kernel build script. So the Slackware kernel package build script executes this, and as does the installer. So that list is a shared list. What I'm doing here is I'm just the way we're going to do this is live. So we're going to make the changes to the initial RAM disk when it's booted and in RAM, and we're going to do that before any of the other. Before any of the kernel modules are set or before any of the modules are attempted to be loaded. So what I'm just showing you here is I've added the SLK PBS token to the command line, the kernel command line. I've edited the bootloader config, and that's what I've done. So I've just added that SLK PBS, and that tells the Slackware AArch64 kernel module loader to open up a shell at 3 different stages. Was it 4? think it's
three.
It's three different stages throughout the kernel module loading process. So this gives you absolute control over the bootloader process, pretty much, as you'll see. What am I doing here? Okay, so I was testing it on the Raspberry Pi 4 initially, and I was just trying to see whether I'd installed my Raspberry Pi kernel fork package, or it was the generic one. I know because the RPI one has an RPI and a build number. Yeah, I think that's right. Okay, so I've rebooted the Raspberry Pi. Let's skip forward. Okay, so we've opened up the first stage of the shell. This is nothing. Basically, this is there's no kernel modules lists being set. There's no modules loaded. This is basically before any of the sort of business logic kicks off about setting up the environment. It's completely like the very first step. The kernel's booted and it's like, hey, here's a shell. We're not doing anything else, dude. It's the bare minimum running here. There's no kernel modules running, nothing like that. Okay, so at this point, I'm just showing you how large the initial RAM disk is. The footprint in RAM is 364 megs. So that's uncompressed. So that's live in RAM. That's how big the InitRD is. And that's essentially because the kernel modules, there's quite a lot of them. So again, we're going to go and get rid of some of those. Okay, so let's skip through here. Okay, so I'm just basically going to start deleting some kernel modules from here, like this. I don't need to show you all of that. Have I pasted that in? Okay. So, oh wow, so we've already saved ourselves 137 megabytes by deleting these things. So that's that's quite impressive. Okay, now I'm just going to rebuild. So I've deleted the kernel drivers that we had previously decided. We'd already spent time before this figuring out what to delete, and this podcast was purely about recording, but well, basically testing it. We just assumed it was going to be fine, so we just tested it. So I've done that. This is the second stage of the bootloader. So I've exited the first stage. I'm just showing you that the kernel module loader has detected it's a Raspberry Pi 4, and it's set all of the kernel modules that were supposed to be that we need for this hardware model to bring up the OS. Okay, so it's booting. At this point, I think I was saying, were there any errors? And Brent said yes. And so yeah, there we go. So we've deleted more than we needed to. And I'm just checking that. Okay, so there was more. So I was just doing a little bit more sanity checking there. Okay, there you go. Yeah, so there were 3 that we needed. Okay, so I was just locating exactly where it was, and where all 3 of them are actually. Okay. So yeah, so this, as you can see, so this is on a full installation of Slackware. This is the contents of that crypto directory that we just wiped out. So as you can see, there's quite a few in there, but the only one that we actually need, at least for the Raspberry Pi, is we just need a single one of those modules. Well, potentially anyway. Okay, and so I start doing the same thing again. I'm just looking to find out where they actually are, and see what else is in there. Okay, what am I doing now?
Trying to figure out
so
which computer you're on.
Yeah, so I'm rebooting the Raspberry Pi. Yeah, so I'm going to. Okay. Yes, I think so I was just figuring out the command lines to delete this stuff. Okay, so yeah, so basically I was just finding everything so that I can create these lines here. So we can skip through that until there we go. So yeah, so all I'm really doing again is I'm just preparing the list so we can retest it. But that list is actually the include file in the build system. So it's not just a testing script. It's actually going to be, the result of that is going to be run from the build system. So I'm making sure I get it right. There we go. Okay, and I pasted it in. It's booting, and it looks like it's fine. Okay, so next one I'm checking on. We moved, so the Raspberry Pi 4 works. We've got the list pared down and it boots and there's no errors. So then we start looking at the Pinebook Pro. Again, it's exactly the same thing. So boot the machine. I paste in the deletion commands. Oh, that was fast. Okay, cool.
Yeah, we got faster the further in the video we went.
Yeah. Oh, that's right. I was just checking the serial log of the Pinebook Pro. Okay, so then I was messing around because my x86 machine a laptop machine that I use as the serial console machine for the machines in my office. I think it's failing because only 2 of the 3 USB ports work. So I had to replug things, and then when I've noticed that when you disconnect the serial cables out of these serial cables we use for the ARM machines, I've noticed that when I disconnect one of them off, it tends to cause the others to drop the connection as well. I don't know if it's some kind of earthing problem with these cheap things or not. I don't know. It tends to do that. But if I touch any of this USB stuff, it tends to have to disconnect it all and reset it up again. It's quite a pain, actually. Anyway, so we are testing again the Pinebook Pro, I think. Oh no, this is the Block 64. So yeah, so checking on that. Pepper. Yeah, and that was it. So, oh yeah, okay. So we just spent a little bit more time doing some final sanity checking, and yeah, that's basically it. So I think this is what we ended up with in the end. So, so in summary, what we've done here is the initial RAM list was getting too fat. There's just too many modules in there that we really don't need at that. At the first stage boot process, all we need to do is access the storage to bring up the OS. That's pretty much it. So we've gone through, we've eradicated 137 megabytes of superfluous kernel modules. And so that will mean that the kernel package upgrades faster, because when it upgrades the package, it resynchronizes the operating system initial RAM disk. And if there's less, to package up, it's simply going to be faster. Same reason when we boot the machine, there's less data to be read off the storage, so it'll boot slightly faster as well. We'll be pushing these packages out pretty soon, these updated kernel packages, and hopefully everything will work. If there are any issues, we can just add modules back in again, but I think it should be fine. But we'll see. But I'm pretty confident. All right, well, that was good. So that's really it from us. I haven't got anything else to say on this one. I don't know how long we've been talking. 21 minutes. That's great, because originally it was just shy of an hour, wasn't it?
Yeah.
So I'm happy with that.
We should do that more often.
Yeah, maybe we should. It's like a good way of editing it, isn't it?
Just do all the stuff real quick and then talk about it.
Yeah, we could do, couldn't we? I don't know. Not a bad idea. Well, yeah, so I hope that's been interesting for you guys and relaxing, because I find watching people repair their DeLoreans really relaxing, and pulling cars out of the sea and the rivers. So if you guys find watching us do this relaxing, please let me know. I like it to be relaxing as well. It's supposed to be a fun hobby project, so it needs to be relaxing. But yeah, let us know in the comments if you wish. Somebody, by the way, did ask on one of the comments on one of the other videos about the status of the Apple M1. Well, the answer is is what I said earlier about the Apple M2. Yeah, I'll probably do it, and other people can help and play around with it if they want. Post Slackware 15.1 release. All right, over and out. Have a good weekend, Brent. I'll see you
Later.
Bye, everyone. Take care.